how many times do you hear, I'm doing all the things right, I'm exercising, I'm eating low carb, I'm doing this, and the weight is just coming back on. Well, radiation causes insulin resistance. The toxins and LPS, just like you're talking about, if your gut is not fixed, then just throw everything out the window, right? I mean, you have to do the basics, and it's not about the calories. So I want to talk about this true pandemic of insulin resistance. And I have had multiple people just this week say, Sara, this is what I'm eating. My insulin resistance will not come down. What do you do about it? What is causing this inflammation and insulin resistance? It's not sugar. And by the way, sugar, I used to be a Splenda fiend. I would eat tons of it. And then I was eating stevia. Both of those things just totally destroyed the inside of me. My body loves just regular sugar, fruit, and the real carbs, the real food, the way nature intended it. But let's talk about the inflammation and insulin resistance and why sugar is not the cause, but these other things are.
Yeah, and what a concept, right? That the foods that are available to us and are made directly for animals, like fruits, can actually be supportive of our health. But in any case, we have largely done the same thing with insulin resistance and diabetes that we did with cardiovascular disease, right? We looked at cholesterol levels, we looked at plaque, we said those two things go together. High cholesterol must be the driver of cardiovascular disease. We all need to stop eating fat. We have to stop eating saturated fat. We have to avoid cholesterol-containing foods. And we know now that that was a mistake, right? But we've done the same thing when it comes to insulin resistance. We see there's this cellular insulin response issue. There's high levels of glucose in the blood. So these high levels of glucose must be causative. And so we must avoid anything that increases glucose levels. And what we're doing here is treating the symptom, right? We're blaming the firemen for the fire when they aren't actually to blame. They aren't actually causing that situation. They're there because of the issue, because of the underlying problem. So that's, I think, the larger framework we want to consider, or just kind of as a tiptoe in here. But what I would say is actually the driver, what actually is causing the elevated blood sugar and causing the inhibition or the problems with the cellular response to insulin has everything to do with our ability to produce energy. So when our cells have carbohydrates, they have glucose available, but they can't convert them to ATP, the cell A is in a distressed state, but B, it actually has all of the glucose and its metabolites build up because you have all this fuel there and the engine can't convert it into energy and actually do what it needs to do. So the gas tank is essentially overflowing. Insulin's coming around with some more glucose and saying, hey, let's put some more glucose into the cell, but the gas tank is already full. The cell is already full of glucose. And so the real problem here is that our cells are having metabolic problems, right? They're not actually able to convert that fuel coming in into energy. And so then we're seeing this buildup of the fuel. And so where we want to put our focus is not on avoiding the fuel. We need that fuel in order to function, in order to produce the ATP in an efficient way. But we want to fix all of the number of things that are going to be involved with actually producing energy from the glucose.
So essentially, there's plenty of gas in the gas tank, but the gas is not being converted into actually making the car run.
Exactly.
Correct? Yeah. Okay. So there's a problem in the function of it. It's not a factor of too much sugar. It's just that it's not being converted. So where does the disruptors, okay, so the cells are stressed. And I know you talk about the body being in survival mode. When the body's in survival mode, it will lower its metabolic rate. It will convert T4 into reverse T3. It's going to build this layer of amazing visceral fat to protect our organs. And all of these things are happening. And your body's going to store fat because we don't know if we're going to be chased by a tiger or have a famine coming up. So how is that triggering insulin resistance?
So if we just look at the hormonal side, and that's a lot of what you were discussing, right? T4 conversion to reverse T3, elevated levels of cortisol, those things have direct effects at the cells, right? The cells are responding to the hormonal state because the hormones are the signals that the body uses to communicate that we're in a low metabolic state. We aren't in a good, comfortable, abundant environment. And so those hormones will directly interfere with mitochondrial function and basically prevent us from converting that glucose to energy for the exact reason that you mentioned. We When we're in that state, we want to be storing fuel. Our bodies are in a storage mode because they're viewing this as scarcity. So they want to be storing the fuel as body fat instead of converting it to energy. And our hormones do this. We know that cortisol does this. For example, we can look at the extreme states of high cortisol, like Cushing syndrome, where somebody's storing lots of body fat just due to these elevated levels of cortisol. And we see the same thing in severe states or even just moderate states of hypothyroidism that you were kind of alluding to. If we don't have enough of the active thyroid hormone T3 and we have a lot of reverse T3, the same process is happening. We're blocking or providing a signal, basically telling the engine not to run so we can go and store that fuel as body fat. And so we have both things going on. On one hand, we have this excess fuel. We see the glucose rise. We see the cells not responding to insulin. We see this state where we're storing body fat. And then at the same time, we have less energy available. So we're not actually functioning and feeling good like we can.
Okay. So the other thing I wanted to focus on, you mentioned the PUFAs and the seed oils. Can you explain how it's not sugar, it's not carbs, these are fats, and we're supposed to be on a high fat ketogenic diet? These wrong fats or bad fats could actually be triggering insulin resistance.
Yeah, absolutely. And they fit right in here. So the polyunsaturated fats, these are, as you said, the seed oils. So this is canola and soy and cottonseed oil, the ones in most of the processed foods or fried foods. They're also going to be found in high amounts in seeds and nuts. That's where they come from. There's a couple of exceptions, but most seeds and nuts are very high in the polyunsaturated fats. And then another kind of hidden source, and you were kind of alluding to this, especially in the low carb, carnivore, keto sphere, chicken and pork are not often considered to be concerning in this way, but they're often very, very high in the polyunsaturated fats because their fat is reflected or will reflect whatever they eat. So they're often being fed a lot of the grains and oils. And so then they have very high amounts of the polyunsaturated fats in their fat as well. So those are some of the main sources of polyunsaturated fats, especially the omega-6s. And when we consume them, there's a couple of things that happen. So for one, these are the least stable fats by far. So when we're comparing the least stable polyunsaturated fats, or some of the least stable, to even monounsaturated, which are a lot more stable, we're talking hundreds of times less stability and more susceptibility to damage. We essentially just have these weak, fragile fats. If you think of, putting oil on a pan that's too hot and it starts to smoke, that same kind of thing is essentially happening internally when we're using those, not even as a fuel, but even just going through digestion, which is a pretty intensive process, and being exposed to our body temperature of 98 degrees, and then also going through all of these oxidative processes in the mitochondria. There's a lot of places where these fats can get damaged. And so that's the first concern. But even worse than that is we are structurally made up of a lot of protein, but also a lot of fat. Every cell has fat in its outer membrane and like the encapsulation of the cell, but also in a lot of the different organelles inside, including the mitochondria. So we're taking these very unstable fats and then incorporating them into the structure of every single cell of our body. And that not only leaves our actual structure susceptible to damage, but it also essentially introduces instability in the structure. If we're thinking the wall of a house, something that we don't want to be introducing a weak building material there. And so another way we can think of this, and we'll kind of, jump around with analogies, but if we think of a hydroelectric dam, that's very similar to how our cells produce energy. We put a lot of hydrogen ions or protons on one side. You can think of that like the water. And then we want to kind of spin it through this one little area. It pushes a wheel around and that makes ATP. That's kind of the general idea. When these fats, these very unstable fats, are used in that dam, it's basically introducing holes into the wall that the water is able to leak through. And so we're running out of all this pressure. We're leaking out all of this potential energy that we could be using to produce ATP. So we can take all of the kind of physiological processes and mechanisms there, but the way that actually looks in real life is we eat these fats and we then can't convert the food that's coming in into energy, and we store it as body fat. So this can't be understated how much of an effect these have. And to leave kind of that category or that subject with one last statement to kind of provide how important these are. When we look between species of all animals that we see on the planet, every animal we can think of, there's different amounts of these fats inside of the structure of the cells. And the number one thing associated with how quickly animals age and how long they live, how long their lifespan is the amount of these polyunsaturated fats. So the more unsaturated our cells are, the shorter we live and the faster we age. And then the opposite, right? The fewer of these unsaturated fats we have inside every cell, the slower we age and longer we live. And we see this across every single species on the planet.